Precalc Chapter 7.1. Today we're going to talk about trig identities. You guys should have touched upon these last year. And last year, hopefully your introduction was good. Basically doing the same thing this year, possibly doing more questions about them, going a little bit deeper than what you did last year. 3/4 of this, or 2/3 of this page, are things that we should already know. So we already covered the fact that the big 3 and the little 3 are connected because they're reciprocals. We also talked about the Pythagorean identities, sine squared plus cosine squared equals 1, and its variations. I told you guys, hey, if you guys just know the first one, you guys can build the others. Then we also should know the even and odd functions, as in if there's a negative angle in sine or tangent, the negative gets to go to the outside. If it's a cosine, then it disappears. Right? So we dealt with a little bit of that. The one thing we didn't talk about yet is the cofunctions. Wait a minute. Do you think there's a link between the fact that we say sine, cosine? Tangent, cotangent, secant, cosecant. Wait a minute. Is there a connection on your unit circle? What's the sine of 30? Guess you know this. Sine of 30? Half. What's the cosine of 60? 1/2. They're the same. They are the same. So, why they are the same is because of cofunctions. And by being cofunctions, notice that the cofunction is 90 minus your angle, or pi over 2, minus your angle. So that means that if you let u equal 60, then, or pi over 3, yeah, I'm recording. I recorded that, and I am recording. Okay, so we have, say, we'll change this to 90 degrees to make it a little easier to understand that if I said u is 60 degrees, then 90 minus 60 is 30. That's sine of 30. It's the same thing as cosine of 60. And we just showed that is true. But it doesn't have to be for the nice angles that we know. If I said u was 50 degrees, so that means the cosine of 50 is the same thing as sine of 40. Now we have more things that we can interchange when we want to. There's more than one way to break up a dollar, right? 4 quarters, 10 dimes, 20 nickels, 100 pennies, 20 pennies, and 8 dimes. Things like that. They're all equivalent. What we're going to do here is we are going to figure out some combinations to simplify, eventually verify one side is equal to the other. So, on our unit circle, some of us are going to have to make new copies, so I'll have to get some more out there because people put their parent stuff on the back. This is what's supposed to go on the back. I don't expect you guys to remember all of these. This is the first box of many. There are 3 lessons in the book that deal with trig identities, which end up having 7 to 8 boxes potentially of different identities that we will use. And so I would not necessarily put this right away and fill up your whole entire back of your paper with just these. Some of these you should already know anyways. So I would write these in your notes first, and then after we get them all, transfer them to the back of your unit circle. If we need a new copy to make a new unit circle that's nice and neat and have all of this in the back, we can make that happen as well. So does everybody have these? So what are we going to do with this? We are going to now simplify the trig expression. I realized that I end up messing up the outline. I fixed it, if you're just looking at it now, that I actually had cotangent there instead of cosine t. But what we're going to do is we are going to simplify cosine t plus tangent t sine t. And to simplify, a lot of times up front here in the beginning, it's the easiest when you think of sines and cosines, because tangents can be turned to sines and cosines as well. So my suggestion is to change everything to sines and cosines and put it together. The whole idea is to get it down to maybe 1 or 2 trig pieces, and that's it. This one has several, has 3 different things, but you can see that some, like tangent, is made up of the others. So, cosine t. Can you change cosine t into other things? Yeah, we can change it into 1 over secant, but that makes it look messier, right? So we're going to leave cosine t. Plus, wait a minute, what's tangent of t? Sine t over? Okay, sine t over cosine t. And we're going to multiply that to sine t. Sine t over 1. That means, can I put that together? Okay. So we are able to put that together. I have cosine t plus sine squared t over cosine t. I got a fraction added to something. If I wanted to put those together, I have to have a common denominator. The denominator of cosine is a 1, so how can I fix that for us? Yeah, multiply tops and bottom of by cosine t to the first fraction there. And I'll eventually now have a common denominator. Hey, that's pretty cool. Isn't that just cosine times cosine is cosine squared t. It's all going to be over cosine t, but plus sine squared t. Are we done? We got it as one thing. Is there any bells going off inside your head? What is it?
1 over cosine.
It becomes 1 over cosine because cosine squared t plus sine squared t is equal to. So it's 1 over cosine t. And wait a minute, that also can be simplified to secant. And I think secant of t is probably the most simplified version you could get of that expression.
Wow.
Everything was logical, right? Everything was there for a reason. Now, I think, guys, this is like playing checkers or even playing chess for sure. When you guys play checkers or chess, do you guys play for the moment?
No.
Is it basically you make a move and then your mind just shuts off waiting for the person to make a move? If you're playing to win, what are you really doing?
Setting the person up.
You're basically thinking, what are they going to do? What is your next move? What is their move after that move? And you're basically thinking or trying to 3 to 4 or more moves ahead, right? And so these are the same way. Eventually, up front here, when you're just simplifying, it sometimes can be a little bit troublesome to figure out where do you stop. I'm hoping that everybody would see that secant of t is a pretty simplified version of what was going on. Yes, we made it a little bit more messy at first. We cleaned that up. Later, we're going to verify. You're going to have one side equal to another side. You will know your answer. What we're going to do is just change one side to the other. We're going to make one look like the other side. So you'll know exactly when to stop. And so what we need to start to do is say, hey, if I got a common denominator, what will that do for me? I don't just do it. I think about it first and say, wait a minute, then I'll have a sine squared and a cosine squared that when I put together will equal 1. So yes, that's what I'm going to do. You kind of seeing how you kind of think about that move before you do it? Kind of say in your mind, what is that going to do for me? Because sometimes there's more than one way to make these things work. There's more than one way to get to the answer. And there's also dead ends. There are things that you're going to start to do, and then all of a sudden go, Well, that didn't work. You need to stop, rewrite the problem, and do it again. Or you're going to do something and find out you just ended up back where you began, and that wasn't right. So you got to try something different. So, our next problem. This one is telling you, hey, let's simplify by actually combining the fractions. We kind of did that last time as well. Think of the same moves of sines and cosines. Try this one on your own. We'll come back. So, we don't have a common denominator, so what is our common denominator? It's cosine times 1 plus sine theta, right? So this one needs a cosine theta and a cosine theta. What you do to the bottom, you do to the... Hey, look at this. I better put parentheses around that, yeah? This one is 1 plus sine theta. Parentheses, 1 plus sine theta, parentheses. Knowing that on the left side and all the denominator, you technically should be distributing. But I'm going to inform you, when you're doing these, don't distribute denominators. Leave them, for the most part, in the beginning, leave them factored. You'll see this in a second. Because if not, then you have to add an extra step in. If I distribute on top, I get sine theta plus sine squared theta plus cosine squared theta. You guys agree with that? All of that is over 1 plus sine theta, cosine theta. What happens? That's 1 again. And so you end up with sine theta plus 1 over 1 plus sine theta times, cosine theta. And then you're like, hey, what's going to happen? Sine theta plus 1 is the same thing as 1 plus sine, so gone. Leaving you with 1 over cosine theta, which is again secant theta. Any questions? So your homework tonight is the first side of worksheet 1 of the Trig Identity packets. Have a great day.